Today, building a somewhat complicated macOS app from scratch. Let's begin. Now. Greet to you, my friends. Today we're going to be building and open sourcing a text snippet app. Some examples of this include TextExpander, Typinator, Espanso, Xcode, and then even the operating system has this feature tucked away in system preferences. What apps like these allow you to do is associate a trigger phrase like xname with some content, such as my name, or my email address, or localhost 3000. It's a useful little utility, but more importantly, it has a nice balance of complexity and implementability. We're going to figure out how something like this might work, and then we're going to implement it using SwiftUI, CoreData, as well as secret, evil, archaic macOS APIs. It should be fun, so let's get right to it. Don't you just love this screen? A wide field. Soon we'll build a shantytown and pollute the river. We'll convert the local fauna into laptop stands. So let's begin. It is of course worth spending many hundreds of hours on this page, yet I've already done this behind the scenes, and we will be calling this spandex. While we're going to use CoreData later, I'm going to be setting that up manually, so let's leave it unchecked for now and hit enter. So the complexity of this application isn't going to be in the UI or the data model. All we really need to get started is a struct which we can call a snippet that has both a trigger, which is the string that you type, and then a content, which is the string that it is replaced by when it matches. The challenge is instead in figuring out how the hell we're going to know what the user is typing into any application. It probably won't be surprising to hear that there's no easy-to-use API for just getting the current text content out of any application's text field. So how do these other apps do it? Well, it turns out that on the Mac, there is a type called NSEvent. The NS part of NSEvent stands for Next, which is the company that Steve Jobs founded after leaving Apple in 1985. And if we fly over to the documentation, we'll see that it was available since macOS 10.0, which came out a long time ago now. And these are all clues that working with this API is going to be slightly less ergonomic than you're used to. But nonetheless, this is the class we wish to concern ourselves with, as it is an object that contains information about an input action, such as a mouse click or a key press. Since we're unable to get the text content out of any text field magically in anyone's app, we're going to have to be slightly more clever, and instead reverse engineer that text content by tracking all of the user's key presses and redundantly storing the contents of their text in our own model. That might sound a little hacky, and it is, and we have to be careful about some edge cases. So let's experiment for a moment with how TextExpander behaves. Let's try using the snippet xname, which is xname. When I hit the E, it's deleted and replaced with my actual name. If we instead type xnam, and then I use the arrow keys to go left and then right, and then hit E, we'll see that it does not expand. Likewise, if I type xnam and then click in the same place and hit E, it also does not expand. If I type some other letter first, like T, and then xname, it does not expand. However, if I type T space and then xname, it does expand again. It will also expand if I type xname and then delete the last two characters and fix it. And lastly, I can type a whole bunch of stuff and delete all the way back to the beginning, and then type it, and it will expand. So we can see that TextExpander is doing some clever things behind the scenes to make sure that expansions don't just trigger randomly, or at least in a way that it feels random to us. So we can imagine that TextExpander is reading all of our NS key events, getting the text off of them, keeping track of them. Even if we add more letters and then delete them, it's tracking the deletes such that when we finally do complete an expansion, it fires. But let's say TextExpander is tracking this string, and then the user clicks somewhere or hits an arrow key. TextExpander basically clears that buffer. And that's because we can't know if the user has switched apps or switched text fields, and then if that user then hit E to start a new sentence, and that then replaced it with their name, that would be pretty strange. So by tracking some string of characters and then resetting it after certain events, it gives a pretty decent user experience. It triggers most of the time when you want it to, and doesn't trigger when you wouldn't want it to. So now let's see how we're actually going to do this. let us build ourselves a class. We can just call this spandex model. And we can make this an observable object just for later. And let's do something interesting when we initialize this. On NS event, there is a static function called add global monitor for events matching handler. So this takes two arguments. We need an event type mask and then a callback. The event type mask specifies which event types we're interested in. So if I hit period, we can see that there are a few of them. But the one we care about is key down. And next we just give it a handler and we accept the event. The API for an NS event object is a little strange because we can see it has absolute X, Y, and Z. These are coordinates. Key presses don't really have coordinates. If we try to access one of these variables on a key press event, everything will explode. And that's because, as we mentioned earlier, NS events might also represent other input events, such as mouse clicks or mouse movements. These older APIs are a little creaky and not as type-safe as we're used to. But there are some variables we can access and that we are concerned with, such as characters, which is the characters associated with a key up or key down event. And since this is the event we're looking for, it should be here. So let's use this, but since it is option, let's get it out in a guard. Let characters equal event.characters, else we'll just return. And then for now we can just print them out, just to see what's going on. And in order to get this running quickly, we can just make a new state object inside of our content view and initialize a spandex model. So now let's run this and see what happens. Going back to the app, I'm going to type in some text, and nothing happens. We don't get any characters printed. And that's because one cannot simply do this. That would be crazy. Any app could monitor all of your key presses. Every app could become a keylogger, essentially. And that would be horribly insecure. For a hint of where to go next, we can inspect the documentation. And we can see down here that it says, key-related events may only be monitored if accessibility is enabled, or if your app is trusted for accessibility access. CAX process is trusted. These accessibility APIs are even older and creakier than the NS event ones, but we're going to have to use them in order to become trusted. Also, in using these APIs, we're foregoing the opportunity to distribute ourselves on the App Store, but that is fine, that's not our intention here. So in order to get trusted, let's go over to our spandex app, and in here we can make a new function called getPermissions. And now we can use one of these archaic APIs, prefixed with AX, called AX_IS_PROCESS_TRUSTED with options. This strange capitalized global function will not only allow us to check if we're trusted, but also prompt the user to trust us. And in order to do this, we need to create a dictionary. And the key value we're going to set is another odd global constant called KAX trusted check option prompt, which is an unmanaged CF string, which we're going to have to call take unretained value on, and then set this equal to true. And then if we compile this, it's going to tell us that this dictionary is not a CF dictionary, so we can accept the autofix there. And then we can add an onAppear callback and call getPermissions in here. But if we try to run this, nothing will change. In order for this function to actually do anything, we need to escape from our app's sandbox. So let's hit Command 1, click on our spandex project, go to Signing in Capabilities, and then delete the sandbox. And now let's go back here, and let's try running this again. This pop-up didn't appear on the right screen because we launched our app from Xcode, but this is what the user will see when you use that strange accessibility prompt function thing. Chances are you've seen a prompt like this before in an application that does anything interesting with the system. So let's click on Open System Preferences. It'll take us to the accessibility section within Security and Privacy. We can unlock, and then we can scroll down and find spandex. Check the box, close it, go back, and now we can try again. So I'll leave this little window running and go back to the app, and up here I will press some keys. I press 2 slashes for a comment, and you can see them below here. And now as I'm typing, hello there world, it looks like we do in fact get the characters off of the key presses. So it looks like this API is going to get the job done, and it wasn't even terribly awkward, save for the somewhat creaky API. Of course, there are some edge cases we need to handle. For instance, if I press the down arrow on my keyboard, we get one of these little Mario-style mystery cube characters. And that's not very helpful at all. We certainly don't want to track that as text that the user has written. And when I press delete, we get an empty space, perhaps an empty set of characters. It's kind of hard to tell. And we do want to know when the user hits delete so we can update our tracked text accordingly. So in order to get this information off of the event, we can call event.keycode. And this will be an unsigned 16-bit integer representing some keyboard key. So let's run this again and see what those values are. When I type hello there world again, we'll see that each letter is represented by a different digit. L is 35, E is 2, space is 49. And then if we hit the left arrow, we get our little Mario cube, but we also get the number 123. And while the cube is the same as when I hit the right arrow key, it has a different number, same with up and down. And delete is 51. So now we can use these key codes to behave differently when certain keys are pressed. So now let's see if we can render the typed text on the screen and also handle delete key presses. So I'm going to close the console, delete this comment, move over here, and because I don't trust myself to remember that the delete key is represented by the number 53, I'm going to create an extension on NSEvent called isDelete, and this will be a boolean, and it will simply check to see if our key code is equal to the number 53. So now, because we made our model an observable object, we can also add an appUblish property called text, and this can start out as an empty string. And now inside of the body of our monitor, we can check to see if the event is delete. If so, we can remove the last element from the text, calling remove last. And we'll also have to reference self here. And otherwise, for now, we can just append onto text our current characters. And let's go down here into this content view and replace this hello world with the model's text value. And then finally, let's add a large frame onto this so we can see everything we care about. And let's run it again. So now when I click on my desktop and then start typing, we can see everything shows up. And if I hit the delete key, nothing happens. And that's because in that tiny slice of time between closing the console and creating my isDelete helper, I forgot the magic key code that represents delete. It is not 53, but 51. So with that fixed, let me run this again. And now I can type hello world, and now I can hit delete. And we can add more things back, delete, it all works. However, if we press an arrow key, we still get these Mario cubes, and of course, clicking doesn't do anything. So we want to reset our text in both of those cases. As you can see, these special keys tend to have really high key codes, so for now, as a little hack, we can just check to see if the event's key code is, say, greater than 100, and if that's the case, we can just reset our text to an empty string. And then in order to handle the clicking, we can copy this global monitor line, and then check for matching mouse down events. We can do both left mouse down, as well as right mouse down, as well as, I guess, other mouse down, the secret mouse. And in here, we'll just also reset our text to an empty string. So now let's run this again. I'm going to click onto the desktop, type hello world, delete a few characters, hit the left key, it disappears. Typing hello again, I'm going to click back into my app, and that did nothing. And also I should say that when I type into my app, nothing changes either. And that's because we are monitoring global key events. And if you want to also monitor the events that are affecting your app, you have to monitor local key events. But if I were to click back out into the desktop, it does delete correctly. So if we go back, we can see that there is on NSEvent another function called monitor local events or add local monitor for events. And as it says, this will install an event monitor that receives copies of events posted to this application before they are dispatched. And while we could add this, I really don't mind the behavior of snippets not firing inside of our own app. But if that ends up being annoying, we can just add that later. I'll delete it for now. And just while typing delete in here, it looks like I have triggered an error, because our text was empty when I tried to hit delete. So let's also make sure that our text is not empty. Lovely. So now that we have demystified the process of tracking what the user is typing into any application, let's take a look at what we need to focus on next. Let's make a mini to-do list up here. So we've handled text tracking, that's done. And next we can tackle snippet matching. In order to do this, every time the user enters a new character, we can check against our list of snippets and see if any of the triggers match what they've typed. That one shouldn't be too hard. And lastly, we'll need to actually insert the content of the snippet. And this itself is actually a two-step process wherein first we must delete the trigger, and then we have to insert the content. And of course, just as before with the text tracking, we'll need to be able to do this no matter where the user is typing into any application. So this is also going to involve some other strange, archaic APIs. So before we return again down that dark path, let's first get an easy win under our belt and implement snippet matching. And in order to do this, it would be great if we had some example snippets to work with. So let's go up to Snippet, create an extension on it, and we can make a static variable called examples. And this will just be an array of snippets. And in here, we can make a new one. Let's just do the one I used before, which is my name. And then also some random website. And then also, to get meta, we can have a snippet for creating new snippets. So let's escape these nested double quotes. And then we can replace the content with Xcode placeholders, which are, if you didn't know, angle bracket, pound sign, some text, pound sign, then the right angle bracket. And this will still render like a placeholder, but I don't think it will complain. If I try to build this, it doesn't give the usual placeholder found in source code error. So now let's use these examples. In the model, I will add a new published variable called snippets, and for now, these can just be our examples. And then I'm going to add a new function called match snippet. And we're going to call this every time our text changes. In here, we want to find the first snippet that matches the text. So we can say if let match equals snippets.first where that snippet matches our text. Of course, this function doesn't exist yet, but we're going to add that next. And once we have that match, we're going to call another non-existent function called insert snippet, and we're going to pass that match along. And we can just define this down here. And for now, we can just log this. So now let's define a matches function on snippet. I'm going to add this up here, and it's going to accept as its argument a string to match against. This will be the text content, and it will return a Boolean. For now, let's just return true. And now that we've prevented our screen from being overtaken by error messages, let's write a little doc comment to think through the logic. Let's say we're calling this on the snippet below with the trigger of xname. What sorts of strings should match this? Well, obviously xname should match, as well as xname with a space in front of it, as well with some text and then a space and then xname. But it should not be matched by something that's not the trigger at all, something that's almost the trigger, or the trigger prefixed by some other characters without a space. I'm not sure if this function quite deserves it, but just to prove a point, when encountering a function that surpasses a certain threshold of complexity, where it might be a little tricky to get right, or I won't be completely confident that I've gotten it right just by looking at the code, and most importantly, where it's just a pure function that just takes some data and outputs some data, and the output will always be the same given the same input. In other words, if I'm testing a slightly complicated pure function, I sometimes make unit tests. You're always going to have to test your code, it's just a matter of whether or not that's manually or in an automated fashion. Certain things are difficult to test using automated testing. And if you're a solo developer, if some piece of code isn't going to change very often, it's okay to just run those manually. There's a whole lot of philosophy and guilt around testing, but my perspective is I want to write the thing that works in the least amount of time possible. And sometimes, especially in cases like this where I'm dealing with complicated logic involving pure functions, automated testing actually speeds up that process, because I want to make sure that the function I write matches all of these cases, and I don't want to manually test each of these cases every time I make a change to my function. Obviously, there are other factors involved, such as whether or not you're being paid to write the tests, or whether or not there are lives at stake. But if you're a solo developer, or part of a small team, or just messing around, things get a lot simpler and a lot less guilt-ridden and complicated and philosophical if you just treat tests like a tool. And now that we have talked about testing for longer than it would have taken to write the tests in the first place, as is usual, let's just write the tests. So in order to do this, we can go up to our File menu and make a new target. And this will be a unit testing bundle called spandex tests. Now let's open that up in our sidebar. We can delete this setup and teardown logic, as well as the performance test and the comment, and then change the name of this to say test snippet matching. And in order to test the function we've written, we can say testable import spandex, so we don't have to worry about public-private modifiers, and then we can write some assertions. First we'll need a snippet, so let's rebuild xname from the other page. And let me also grab that comment string. So we can use xct assert, which will pass if we return true, or fail if we return false. So let's say snippet.matches xname, xname with a space, xname with some other text and then a space. And then we can make sure that it does not match xnot, or xnom, or fixname. Now we can run this by hitting Command U for tust. Tust, a name you can trust. And it looks like we've passed half of our tests, and that's because we've returned true. So now let's get to the actual implementation. We can begin just by checking that the string has the suffix of our trigger, and let's assign this to a variable. This actually gets us most of the way there if I replace the return value with has suffix and then hit Command U to run the tests again. We'll see that this passes every case except for the last one. And this is because has suffix does not distinguish between a suffix that is at a word boundary and one that is not at a word boundary. And that is really the extra bit of logic that our function requires. So let's go back to Content View and check to see if we're at a boundary. Out of the many possible ways of implementing this function, one relatively simple way is to take our string and drop the last trigger characters. So we're dropping the length of our trigger from the string, and then on this we can call last, which will return the last character, or nothing if it's an empty string. And this will be an empty string if the string is exactly our trigger. So to make this short and sweet, we can replace that nil with something that's going to pass our next check, which will be a white space, and then check to see if this is indeed a white space. And then we can join this onto our other assertion. So this function is now both checking that the string ends in our trigger, as well as that the character directly preceding our trigger, if it exists, is a white space. So now let's hit Command U again. And they all passed. Huzzah. So now to visualize how this is working, let's add some UI that we'll need later anyhow. Let's wrap our body in a VStack. And then let's add a list below the text of our snippets, using as the ID the snippet's trigger. And for rendering our snippet, let's make an HStack with two texts inside, one for our snippet's trigger and another for our snippet's content. We'll give the content a line limit of 1, and then purely for our testing purposes, we can remove this in a moment. If the snippet matches our model's text, then we can use the color red. Otherwise, we can use our primary color. So let's run this and see if it does anything interesting. I'm going to type xname, that matches. I'm going to click, type xsite, that matches. Clicking again, xsnippet, that matches. I can type some other words, type xname, it matches. I can delete, type it in the end of another word, it doesn't match, and so on and so forth. Everything seems to be working as expected. So now let's go back, and now we can work on snapping in that final puzzle piece, which is inserting the content of the snippet. So how is this going to work? Well, as mentioned previously, this actually consists of a couple of steps. First, we need to delete the trigger content, and then we need to insert the actual content. So how can we delete something programmatically? Just as there was no API for reading from any text field, there is also no API for just deleting any text field. So how does the user delete things? Generally, they press the delete key on their keyboard, but coding something to do that would be both dangerous and illegal. So what happens after the user presses delete? What does pressing delete do? Did I hear you say dispatches a Quartz event to the Windows server? You're absolutely correct. So now we're starting to venture into an even stranger two-letter prefix domain. Before we were looking at NS events for next step events, the system that was the precursor to macOS 10. But here we're looking at a CG event, which stands for CoreGraphics. It's a little weird that key presses are contained within a framework called CoreGraphics, but these APIs are pretty old and strange. So let's read. Low-level hardware events of this type are referred to as Quartz events. Quartz, which, etymologically speaking, comes from the German Quartz, or Quarty, meaning hard, which is appropriate because this is hard. A typical event in macOS originates when the user manipulates an input device, such as a mouse or a keyboard. Fascinating. And then the device driver associated with that device, through the I/O kit, that's me, creates a low-level event, puts it in the Windows server's event queue, and then notifies the Windows server. Okay, we really don't need to know most of this stuff. This is all to highlight that this code is quite low-level and is going to be somewhat awkward to work with. Basically, what's going to happen is that we're going to create one of these events from scratch, and then we're going to post the event, submitting this so-called Quartz event to an event stream. What this is going to allow us to do is generate the same type of Quartz event that would be generated when the user manipulates their delete key. And we can do this all programmatically. And because this is so low level, it's not as simple as just tapping a delete key. If you remember how before we were watching key down events, well, now we have to post both a key down event for pressing the delete key down and then releasing it. We generally don't care about these two events when manipulating our keyboard, but the operating system certainly does. So let's make a new function called delete. So first we can build our key down event, which needs to be a CG event. And as you can see, there are also mouse events and scroll wheel events, but we want to initialize a keyboard event. And so we're going to need this thing called a CG event source. We're going to use the state ID constructor and say combined session state. Don't worry about why. I'm not sure why. I don't want to know why. I'm going to break this onto multiple lines. Next, we'll need a keycode. And now I will not forget that delete is the number 51. And this is the key down event. And then we can copy this to make our key up event. And lastly, we can share the event source between them. And now that we have both of our events, we can first post the key down event, and this needs a tap location, and we can just pick this guy, and we can do the same thing with our key up event. You might be asking yourself, Kit, wow, you're a master of the dark arts. How did you learn all this stuff? It's so strange. But no, I simply Googled in my caveman vernacular, how simulate keypress Swift, and found simulate keypress using Swift. And there are a whole bunch of answers, and then one of these sort of does what I've done here. When exploring the outskirts of AppKit or UIKit or macOS, it is not uncommon to accrue about 1,000 tabs at the top of your screen as you plunge deeper into madness. And that is okay. There is no shame in that. This is normal. I obviously cut this part out of the videos because I don't want them to be 37 hours long. But it is part of it. It sort of mirrors the decision-making process I talked about in the Build Your Own SwiftUI text field videos, in that you have to decide where it's worth spending your time. A good tactic is to say, before I dive into the documentation and buy a book on CoreGraphics, retreat to a mountain and spend 10 years reading there, perhaps I can spend an hour or two to just see if I can hack together, MacGyver using Stack Overflow and some spit, a solution to this immediate problem. If your app doesn't hinge on understanding the details of CoreGraphics, then you're fine. And that's the trade-off I took here. And obviously when recording a screencast, one is able to disguise their ignorance with fancy editing tricks. So now let's see if we can actually get deletion to work. If we have not just screwed up royally, we should at least be able to match a snippet and then immediately delete it. So for each character in our snippets trigger, we can simply call delete, and we can replace char with an underscore. So let's see if this works. Okay, it's running, and now I'm going to type in xname, and it got deleted. I didn't do that, I promise. I can type in xsnippet, and it's deleted. Wow. So that's brilliant. We are halfway there, at least in Zeno's paradox terms. So finally, let us complete the circle and insert the content for the trigger we just deleted. You might be wondering if we're going to simulate pressing every key for every character in the content, but certain content strings would probably be difficult to map to key codes, imagining if some characters require Option or Shift to be held, or they're not even typable with the given keyboard layout. So instead, we're going to take a different approach. Luckily, there is an API for interacting with the clipboard, or the pasteboard as it's called here, NS pasteboard, in fact. So what we can do is first save the old clipboard so we don't override their clipboard. That would be very annoying if our app did that. And then we can update the clipboard to be the contents of our snippet contents. And then we can hit Command V. And we can do this programmatically just as we did delete by posting a CG event. And then lastly, returning the clipboard to its old state. So let's take this one step at a time. First, let's get the old clipboard. So we're going to say nspasteboard.general.string for type string. And now that we have that value safely typed away, we can say nspasteboard.general.setString, and then we can use our snippets content and set that to type string. And then just so we don't forget, we can skip ahead to line 4 and set the pasteboard's content back to our old clipboard content, which is unfortunately optional, so I can make sure that the old clipboard is actually there, and then do that. And just to be extra safe and annoying, when dealing with these APIs, there's a little bit of a delay, so I'm going to wrap this in an async call. 200 milliseconds seems to be long enough in my testing. Unfortunately, we don't have the right to tell frameworks like NSPasteboard or CGEvent to drop everything they're doing and obey our commands, so we have to work in a little bit of wiggle room. Otherwise, you might end up pasting the old clipboard item. So lastly, let's make a function just like delete that instead hits Command V. I'll call this paste. And then let's look at the body of delete. And before we refactor anything, let's just duplicate this and get that to work. While we could go off and hunt down the keycode for the letter V, that will unfortunately not work for me because I use a keyboard layout called Dvorak, which is why when I was typing in nonsense letters earlier, they tend to involve lots of vowels, as these are the letters that comprise the home row for Dvorak. Dvorak is, by the way, the best thing ever, and I highly recommend switching over to it. You'll get the added bonus of people thinking that they're having an aneurysm whenever they try to borrow your computer. What was I saying? Oh yes. These keycodes are unfortunately built around the QWERTY keyboard layout. So if I plug in the keycode for the letter V on my keyboard, this will end up hitting Command K instead, which does nothing as far as I'm aware. And while I think there is some built-in faculty for translating keycodes between different layouts, the code is orders of magnitude more nightmarish and horrifying than anything we've done so far. So instead, we will turn to a third party. Beautifully, there is this open source library called Sauce, which is for mapping various keyboard layout sources and keycodes in macOS. For example, QWERTY and the superior Dvorak, which is exactly what we want to do in this case. In fact, right here in their motivation section, it overviews the exact problem we're experiencing, saying that the keycodes in the Carbon framework only use the ANSI standard keyboard layout, and therefore we can only obtain keycodes for the QWERTY keyboard. So apparently the letter V has the keycode of 9 in QWERTY, but 47 in Dvorak. So let's just use this. They have solved our problem. What we need to do is copy the URL, and then we can go back to the app, go up here, up here, up here, up here, up here, up here, hit enter. And then enter again. And it's installed. So let's go back. Let's go to the top of the page. Let's import the sweet sauce. Let's go back down. And now we can get the keycode for the letter V by saying let keycode is equal to sauce.shared.keycode by.v. Beautiful. So I'll replace this with keycode and this with keycode. And finally, right now this is only going to tap the letter V, so we want to hit Command V, and in order to do that, we can modify our keydown event by inspecting its flags and inserting .maskCommand. Very logical, great API. Okay, and now let's try this. It is running, and now I'm going to make a new line. I'm going to type in my name. And we got what was on my keyboard. This was the problem I was outlining before. First, I'm going to try increasing this deadline again. Running it again. Xname. Same problem. I was hoping I wouldn't have to do this, but there is another little piece of the incantation. Before this line, I'm going to inform our friendly pasteboard that it should get ready, and I'm going to declare the types I'm about to propose to it. I'm going to give it a new string, and there will be no owner. It's an odd incantation, but if you read the documentation for this, it says this will prepare the receiver for a change in its contents by declaring the new types of data it will contain and a new owner. Whatever, let's try it. Running again, typing my name. It worked. That's amazing. Okay, let's scroll to the top. Let's go here, let's go here, let's go here. Let's use Xsnippet to conveniently create a new snippet. Celebrate. Celebration. I'm rerunning. And now, celebrate. Incredible. So now that we have the core functionality of this app working, this is a good place to take a rest. And in the next video, we can build the UI using SwiftUI and CoreData for persisting and creating snippets, as well as making sure that our snippets cannot trigger themselves during expansion, because then we'll end up in a nightmare recursive hell loop. But I hope this has been fun. Once again, I will put this code, what I have so far, on GitHub. And of course, if you're into it, feel free to subscribe as well as like this video. Or check out the other videos I've made. I've made 4 now. I'm a veritable influencer, replete with a Patreon page. Please assist me in amassing a mountain's worth of LaCroix with which to keep my vocal cords nice and moist during the marathon recording sessions these take. Bless you, Oliver. You are a hero, Oliver Pan, my single and only and best patron. If some more folks sign up, I think it could be interesting to do some live streams and share some looser materials, experimenting, building my own apps, etc. But either way, I've committed to making at least 10 videos, which is 6 more, not counting this one, and I'll see how insane I've gone by the end of that. Thank you for stomaching that solicitation. I bid you adieu until next time. Good day.